Hi, I'm Leslie Sturmer with the University of Florida Shellfish Aquaculture Extension Program. This project addresses unexplained oyster mortalities experienced by Florida growers in late spring and early summer, with reported mortalities at some lease locations of 50 to 90% of oysters reaching market size. This is not just a local issue, but a problem facing growers in the Gulf of Mexico and southeastern U.S. With some funding through the University of Florida, a pilot study was initiated in 2020 to determine basic but key relationships between production and health of cultured oysters and environmental factors. The objectives were fourfold: monitor oyster growth and survival at commercial lease areas, compare performance of two triploid lines, one created with the new Florida tetraploids and the other with the traditional Louisiana tetraploids, examine water quality parameters and phytoplankton abundance, and assess shell parasitism and dermo disease. Commercial farms in two aquaculture use zones participated in this study: Alligator Harbor in Franklin County, where these mortality events have routinely been experienced by growers there, and Oyster Bay in McCulloch County, where they have not. I want to briefly review relevant results from that study. Water temperatures were similar for both lease areas, whereas salinities differed. At Alligator Harbor, salinity was high with little variation, ranging from 28 to 31 over the sample periods. Lower salinities were observed at Oyster Bay, ranging from 23 to 18 over the same periods. In these graphs, interval mortality is displayed as bars and cumulative mortality, or mortality over time, as lines. The top graph shows results from Alligator Harbor, the lower graph of Oyster Bay. Florida triploids are represented in orange and Louisiana trips in blue. Mortality was negligible, less than 2% for both stocks and locations through March. Over the next 2 months, mortalities at Alligator Harbor were 28 and 31% as temperatures increased. Note, for this time of year, growers may find these results to be acceptable. At Oyster Bay, interval mortalities at that time were 8 and 13%. Again, that's the end of May, and doubled, though, by mid-July, resulting in a cumulative mortality of 25% for the Florida line and 40% for the Louisiana line. A statistical framework was used to examine how environmental, health, and site factors affected oyster mortality responses. As just shown, sampling period, or time, was the strongest effect observed, with a significant interaction between location and sample period. Higher salinities and temperatures influenced mortality. Florida triploids demonstrated lower mortality than Louisiana triploids, and differences between these genetic stocks indicated the potential to develop a line with higher resistance to environmental stressors and mortality events. In 2023, we expanded the pilot study by increasing the number of farms to provide greater replication across the state and evaluate various growing environments. A network of growers at 8 water bodies was identified in 7 counties on both coasts. Growers were provided with tools to obtain experimental data from commercial farms. The farm's components included providing oysters of the same stock to growers, serving as sentinel oysters, monitoring water quality on the farm, and assessing oyster health. About 700 triploid oysters reared by UF in Cedar Key as part of the urchin study reported earlier in this workshop were distributed to growers in April and early May. These were large, about 75 millimeters or 3 inches in shell height, but we wanted to start the project and assess survival of oysters at harvest size during the at-risk months. Growers used their own culture gear and provided routine maintenance. They were to report mortalities throughout the summer months. For areas where water quality data was not available, in situ Aquatrol 100 data loggers were given to growers, allowing temperature and salinity to be measured continuously inside a culture bag. Growers downloaded data on the farm via mobile app and Bluetooth. Water quality data was then posted to a dashboard and archived as monthly graphs on the UF website. To assess oyster health, kits were provided to growers to ship samples to John Roberts, a pathologist at the UF College of Veterinary Medicine. Histology, an important microscopic screening tool, was used to detect the presence of major pathogens and pathological conditions. The stained histo slides were scanned and annotated using algorithms for 3 tissue types: gills, mantle, gastric mass, or GI tract. The algorithms provided instructions so artificial intelligence, or AI, could be used in analyzing the slides. Values for normal tissues were evaluated against pathological conditions by area quantification. Oysters were assessed in February prior to distribution to growers, serving as a baseline. First, look on the right at the algorithm developed for the visceral body or GI tract. Different colors are used to define various tissues, cells, and parasites. Then each paired image is of a histo slide with the traditional H&E purple stain and the same slide with the algorithm applied. These oysters were healthy. Fat cells in visceral body contain stored lipid. Those are colored a light tan, and undifferentiated gonads. In the gills, mucus-containing cells are colored blue, and cells have differentiation. There's minimum hemocyte infiltration in the mantle, and fat cells contain stored lipid. In the next set of slides, information will be presented for each farm location, providing temperature and salinity values and oyster mortality observed by growers during the summer. In these graphs, water temperatures are shown in blue and values are on the left-hand side of the graph. Salinities are in orange and values on the right side of the graph. For the Cedar Key site, salinity averaged 27 with temperatures exceeding 80 degrees Fahrenheit in April, reaching 90 degrees Fahrenheit in June, and obtaining a maximum value of 94 degrees Fahrenheit in August. Minimum mortalities were observed throughout the cultural period. All oyster bags were lost on August 30th due to impacts of Hurricane Idalia. For each farm, there is also an oyster health report. For the Cedar Key oysters sampled in June, there was heavy gill infiltration by hemocytes, but minimum evidence of gill atrophy. Hemocytes are immune cells that participate in the cellular defense of invertebrates. There was a severe infection of Perkensis marinus, and that's colored magenta, in the stomach and all sections of the GI tract. Perkensis is the parasite that is responsible for dermo disease. There was also some fat cell degeneration, which was colored gray, in the visceral mass. At the Indian River Farm on the East Coast, salinities were high, averaging 32, as were temperatures reaching 90 degrees Fahrenheit in May. Crop mortalities of market oysters on the farm, both triploids and diploids, were noted in April. Mortality of sentinel oysters was noted in early June at 30%. By mid-July, mortality exceeded 80%. Here, paired images are of healthy tissues on the left with tissues from the Indian River sentinel oysters on the right. Significant atrophy and hemocytes were observed in the gills. There was a severe Perkensis infection in the GI tract. Dilated hemolymph or fluid sinuses, which are colored light purple, degeneration of fat cells colored gray, and severely shrunken glands colored green were observed in the gastric gland. Grossly, in the bottom left, you see compaction and atrophy of the gland in the picture. At the farm in Mosquito Lagoon, salinities were also high, averaging 32, and overall average temperature of 84 degrees Fahrenheit. Mortality of sentinel oysters in late May was minimum. In mid-August, mortalities observed were around 30%. Overall, oyster samples were fairly healthy. Gills had hemocytes, which are colored dark blue, and deposition of lytic or fat cells, which are colored light yellow. Some oysters had visceral mass dilation with fat cell degeneration. Those are the gray areas. On the right is a comparison of a histology slide with H&E staining versus an AI annotated slide. The gastric gland cells, which are green, are dilated with hemolymph or fluid in the sinuses, colored blue. With the limited water quality data available, salinities at the Alligator Harbor Farm were high, averaging 31. Crop mortalities of market oysters on the farm were minimum in June, with mortality of sentinel oysters in mid-June less than 5% reported by the grower. Overall, the oysters sampled were healthy. There was a good immune response with hemocytosis observed in the gills. There were non-degenerated fat cells and a mild Parkinson's infection in the visceral mass. The picture on the left shows a healthy, well-conditioned oyster with abundant lytic or fat reserves in the gills and polyps. Salinities at Rattlesnake Cove in Apalachicola Bay were less than 20 in April, ranging from 20 to 30 during the remaining period, with an average of about 22. Temperatures were also wide-ranging, less than 80 degrees Fahrenheit in July, with an overall average of 82 degrees Fahrenheit. Information on crop mortalities of market oysters on the farm or sentinel oysters was not available. Oysters were fairly healthy. Gills have hemocytes, which are colored the dark blue, and deposition of lytic or fat cells, those are the white-colored cells. Parkinson's and magenta was found in the visceral mass, but no signs of pathology. Salinities were low, less than 10 at the Indian Pass farm in April, increasing to over 30 in June with an overall average of 28. Temperatures did not reach 90 degrees Fahrenheit until July. Crop mortalities of market oysters on the farm in mid-June was less than 15%. Mortality of the sentinel oysters was 39% in mid-June, increasing to about 55% in mid-August, but these oysters were very large by then. Overall, the oyster samples in June were healthy. Some individuals had severe Parkinson's infection in the stomach. Again, that's colored magenta. There were abundant fat cell reserves in the gills and visceral mass, and only mild atrophy and compaction of the gastric gland. The salinities at the Pensacola Bay farm were the lowest of all sites, less than 10 in June and July, with an overall average of 16. Temperatures reached 90 degrees Fahrenheit in June and averaged 84. Mortalities of market oysters on the farm were noted in early June, with mortality of sentinel oysters estimated then at 16%, increasing monthly with an overall mortality of 70% by mid-August reported. Again, paired images are of a healthy oyster sample on the left and the sentinel oyster sample on the right. Severe gill atrophy of soft tissue was observed with an average loss of 50%. Although the size of the gill filament, which is colored orange, is unchanged, the gill cells, gland cells, and mucus differentiation was lost. On the picture in the lower right, you see gills with atrophy that are blunted, pale, and have splits between the gill filaments. They do not extend to the mantle fringe. The mantle epithelium is full of hemocytes, which are colored that dark blue. There was moderate Parkinson's prevalence and moderate fat cell degeneration in some individuals. The farm's network in 2023 was increased to include 2 more growers and 1 more county. 10,000 triploid seed from the Florida line and half-sibling diploids were distributed to growers in August and September. Growers report management practices and harvest information in 2024 this year. Shipping kits were provided for health samples if a mortality event occurred. There are plans to continue. So what's next? The network will be expanded to growers, researchers, and extension agents in the South from Virginia to Texas, with funding recently awarded through a NOAA grant. This project will begin next year in 2025. Applications of the farm's network include determining effects of environment and culture conditions on crops, creating awareness of stressful environmental conditions, better understanding of mortalities, developing baselines to compare performance at farm sites over time, documenting performance across farms using the same seed stocks, sharing of information and ideas, and just as important, strengthening connections within the oyster community in Florida. Additional information about the Farms Network and water quality information can be found at the online resource guide for Florida Shellfish Aquaculture website. You can scan the QR code on the right to reach the website. Lastly, I would like to thank and acknowledge all those oyster growers who are participating in this network.